Which of the following best describes the Boolean expression shown below? Okay, so notice that we have A or and then not B and not C. So this has to be A is true, or it has to be not B and also not C. If we distribute the not using the Morgans to the left side of the logical, to the logical, and then the right side of the logical. So will the value always be true? Well, here's an example that will prove that this is not correct. If A was false, and then B is true, and then C is true, then I have false or false and false, which is false. So it's not always true. In the same way, I can show an example that shows that it is not always false. So what if A is true and B is false and C is false? Well, then I have true or true and true, which is true. So the result is not always true or always false. It really depends on what the values of A, B, and C are. Now, these other statements, the other two statements here for C and D are also incorrect. Okay? Notice that C is saying the resulting true value is true only when A is true. So if I show an example where A is actually false, but it's still true, then this will prove this as an incorrect statement. Here we go. So if A is false, but I have B is false, and I have C is false, then it would be false or true and true, which true and true would be true. Remember, you apply the logical and first, and then false or true is true. So I have just shown here that the resulting value is true even when A was false. So none of these statements really are saying what the resulting truth value is. None of them describe it. It is more complex than that. It just depends on what the values of A, B, and C are.